Welcome back. We're going to do RIP algorithm. This is a distributed algorithm to determine forwarding tables. Okay, so a forwarding table is a list of destinations, costs to the destination, to each destination, and the what's called the next hop, or you could say the first hop, but how the first place you have to go to get to that destination. That's a forwarding table. We did that in the in Dijkstra's algorithm, another video. Okay, this is a distributed algorithm because processing is done at each node. All right, each node is doing a little bit of the calculations. It's also a gossip-oriented node, I like to say, a gossip-driven, you could say, because the way it works is each node talks to its neighbors. So let me just say each node tells its immediate neighbors info that it knows about destinations. So each node tells its immediate neighbors about final destinations that node knows about. All right, so let's just work one here. So let's say we have this little tree, or a graph rather, that represents the network. So we've got all of these nodes and the cost to get to each one of these nodes here, the link weights. So this is a graph. So it's helpful for this algorithm to list the adjacency list. So A has neighbors B and neighbors C, right? A has neighbors B and C, and it's also good to store the edge weight in the adjacency list. So it looks like this. So A has neighbors B, and then it costs 1 to get to neighbor B, and A has neighbor C, and it costs 2. So A has neighbors B and C, and it costs 1 and 2 respectively to get to them. And do that for every one of these guys. This is just a convenient way to store the data. So B has neighbors A, and it costs 1 to get to A, and he has neighbor D, and it costs 3 to get to D, right? B has neighbor A and D, and 1 and 3 cost. And C has neighbor A, and it's 2 away, and neighbor D, and it's 1 away. So the order in this list is not really important. It's just a list of every node's neighbors. So, right, A, B, C, D, and E, and F are the nodes, and each one of these nodes has so many neighbors. So D has 4 neighbors, right? B, C, E, and F. So D has neighbor B, 3 away, C, 1 away, E, 3 away, F, 2 away. E has neighbor just D, he's lonely all by himself, just with one guy to talk to, and F has neighbor D, 2 away, all right? So this is the adjacency list. Okay, now this is sort of a gossip-driven thing. So like A is physically connected to B and C. That is, he has a wire coming out of him that connects to B and C. Or it could be some other kind of network. It could be Wi-Fi, right? But A is connected to B and C by some network, Wi-Fi, Ethernet, something, right? And B, likewise, is connected to A and D by some network. So when these computers turn on in the morning, let's say, all they know about is who they're connected to, right? A knows about B and C, B knows about A and D, E knows about D. That's all they know. But then they start to talk to each other. They start to tell each other about their neighbors. Okay, so what's going to happen is A will wake up and learn about B and C. B will wake up and learn about A and D because he's connected to A and D. But then B will talk to his neighbor A and tell him about D, right? So A will find out about D via his neighbor B. And then so A will store this final destination D in his forwarding table, okay? And it kind of goes like that. Eventually E D will know about E, and then D will tell B about E, right? D will tell B. Sorry, D. Pointing at. Let me point at the right stuff. So D knows about E when he wakes up, and D will tell B about E, and then B will know about E, and then B will tell A about E. So eventually the network, the gossip, about nodes telling each other about other nodes will spread, and we'll have the total information. So I have these charts here because you got to keep track of a lot of stuff. So I made these little guys here. So okay, so you have information stored at node A, B, C, D, E, F. Initially, this in here is just this adjacency list, because what it says is initially, well, first of all, the diagonals are not needed because A knows about A. A knows about A, but A knows about his neighbor B, and he's 1 away, and he knows about his neighbor C, and it's 2 away. So this says that A can get to destination B via neighbor B, and the total cost is 1. A can get to final destination C via his neighbor C, and the total cost is 2. Likewise, B is connected to A, and its total cost is 1, and he's connected to D, and the total cost is 3. Let me just fill this out. C is connected to, well, really the way to say it is C knows about final destination A via his neighbor A. So this up here, this first row, these are final destinations. And the stuff in here is next hop information. It's next hop and total cost to each destination. All right, so let me continue to fill this out. So C knows C, A2, and D, D1. And then D knows about B, C, E, and F. Initially, it's just the neighbor information. So D knows about B, and it's 3 away. He knows about C, and it's 1 away. He knows about E, and it's 3 away. He knows about F, and it's 2 away. E only knows about D, and he's 3 away. D, and he's 3 away. And F only knows about D, and he's 2 away. All right. So what's going to happen is, well, first, this is the information at startup. It's just the adjacency list. Basically what it's saying is that A only knows how to get to B and C when he first wakes up because he's physically connected to him. Likewise, B only knows about A and D because he's physically connected to him. Like that. And one more. C only knows about A and D. C only knows about A and D because he's physically connected to them. But they're going to talk to each other. So first of all, B is going to talk to A and tell him about his neighbor D. Basically, B is going to send this information, D3, he's going to send it to A, and then A will find out, hey, I can get to this guy D. I have a new destination. I can get to this guy D. D, it costs 4 away, and it's via B. So the number in here is B4. Because what it says is A has a new destination that it can get to. A has a new destination that it can get to, D. And he gets there via his neighbor B, and the total cost is 4. Okay? And so that's the first cycle, is that A will find out about D via B. And let's see, A will also talk to C and find out about D, right? Because C knows about D. So C will tell A about D. So C will send this information D1. He'll send it to A. A will find out about D via his neighbor C, and the total cost is 3. So it's not gonna. It's right. It's better. So right now, like let's say A talked to B first. He found out about D, and it was 4. So he wrote down B4. But now A talks to C and finds out about D, and it's cheaper. So this is going to change to C3 because 3 is cheaper than 4. So let me just say that again. Initially, A woke up, he talked to B, found out about D, and found out that he can send information to D, and the total cost was 4. And then he was happy for a while, but then he talks to his neighbor C, and C says, "Oh yeah, I know that guy D. I can get you to D for 1." And A says, "Well, that'd be total cost of 3. That's better." Okay, so it's supply and demand kind of. It's like here's an analogy for you. I like honey, from bees. So I have a honey guy. I have a guy I know that I buy honey from. And that's all I know, is that I go to this guy and I get my honey from him. I don't know where he gets it from, but I go to him and he says it's $20 for some honey, and so I give him $20 and I get honey. Now I might find somebody else that has honey for $15, and then I would go to him. Or it could, my first honey guy who I originally bought honey for $20, all of a sudden maybe he could find somebody better, right? And then the price goes down. So it's kind of like that. You're looking a little bit. Anyway, let's see if we can finish this crazy thing, and then I'll show you. The first thing to understand on this is the concept. And once you understand the idea of this nodes telling each other nodes about neighbors, and then the paths getting updated, once you understand that, the hardest part about this is not messing it up. Okay? So I have a little mechanical process I use to keep this stuff straight. But let's just see if we can do a couple more of these suckers before we look at that process. All right. So so that's what A found out about. A found out about this guy D, right? First A woke up and knew about B and C, then he found out about D via B, and then he got a little better and found out about C. What about B, let's say? What happens to B? B wakes up in the morning, all he knows about is A 1 away and D 3 away. So B writes this information A1 and D3. And then A is not going to tell him anything because he is. A is going to tell B about C. Right? So B will find a way to get to this destination C via A, and the total cost is 3. Right? Because B can get to C now via A, and the total path length is 3. So that's what this A3 means. It means that node B here can get to destination C via his neighbor A, and the total cost is 3. Right? So that's kind of how it goes, and you keep on going like that. Let's see if I can finish this B row. B's going to talk to A and find out about C, and that's it. And then B's going to talk to D, right, and find out about E and F, right? So B is going to find out that if he goes to node D, he can get to this guy E, and the total cost is 6. So D6 goes here. E is also going to find out about F from D, and the total cost is 5, right? So D5, because B can get to destination F via total path length of 5. And D can get to B. So we're on row B here. B can get to destination E via neighbor D, total path length 6. That's the concept. Then you would complete this table here, and then the next cycle would iterate where A would find out about E eventually, right? So right now let's do the next cycle. And then I'll show you kind of a mechanical process to do this. So after the first cycle iterates, and you're going to get more information in here, but after the first cycle iterates, what does A know? A knows that he can get to this B via 1, he can get to this C via C, he can get to this D via his neighbor C, and the total cost is 3. B knows about, he knows about his immediate neighbor A, 1. He knows about his immediate neighbor D, 3. But he also knows about this guy E that he can get to via his immediate neighbor D, and the total cost is 6. Okay, so that was what was up here. He also knew about this thing. Now, B knows about D and or knows about E and F now. So he's going to tell A that. So A will find out about destination E, that he can get there via B, and the total cost is 6 plus 1 is 7. A also finds out by talking to his neighbor B, he finds out about this guy named F that B can get to at a cost of 5. So B tells A about final destination F that B knows how to get to via D with a total cost of 5. So A writes down B 6, B6. So what this B6 means, A knows about destination F. He knows that it's a total cost of 6. 1, 2, 3, 4, 5, 6. And the next hop is B. So A knows that he can get to destination F via neighbor B for a total cost of 6. That's the concept. The hard part is not messing this up. So for that, I have a little process that I use. In the end, we want to put numbers in these little squares. So let's say, where does this number come from? Right? So what I do for this number right here, what it means is I'm trying to get from A to D, because I'm on row A, column D. So row A, column D, which means I'm trying to go from A to D. So then what I do is I list the adjacency matrix for A, this thing. All right, so A knows about B1, he knows about C2. That's just the adjacency list, his immediate neighbors. Then what you do is you look for each one of these neighbors, what are they going to tell A about D, right? Because we're trying to get to D. So what is B going to tell A about D? So B is going to put D3 here, because B knows about neighbor, B knows about this guy D. So that you put a D3 there. C knows about neighbor D as well. So you put a D1 here. So basically B tells A about D3, and C tells A about D1. And you put it, we're trying to go from A to D. So these are just going to be always D's here, because that's where we're trying to get. And it's what B1 knows about D, if anything. Right. So once again, what you do, for each square, you're trying to go from A to D, so row to column. So you list the adjacency list, just this adjacency list. And then we're trying to get to D, so you list what B knows about D, which is in here, right? It's this thing. B knows about D, so you put D3. And then what does C know about? What does C know about? There should be a value in here, right? This, oh wait, I'm in the wrong row. C, this is D1, there's a D1 in here, which is up here. Anyway, C knows about D1. So you put a 3. Oh, then the next thing you do is you sum these guys, and you get a 3, and you sum these guys, and you get a 4. 3 is better, so you bring down the C, and that's the answer. That's it. That's the process. It's ugly. It's a little bit confusing, but it's good stuff. Let's do one more, right? What about what goes, where did this value come from? Where did this B7? So what you do is, this is row A, column E, which means we're trying to get from A to E. So we list A's adjacency matrix, or adjacency list. You just list this stuff right here, because these are all the guys that that A could talk to find out about E. And then on here you put, what does B know about E, if anything, and what does C know about E, and then you add it up and you choose the cheapest. So what does B know about E? Well, B knows this D6 thing, right? What does C know about E? At this point, C might not know anything about E. Let's say he doesn't, because it depends on what order you execute these in, which is a whole other thing. But let's say he doesn't know anything about let's say C doesn't know anything about E at this point. So you add this up and you bring the B down. That's the best answer. So you put the B7 in there. Eventually, like, it could be another cycle down in here. Like down in here, C might find out about D. Or rather E. Like up here I'm saying that C doesn't know anything about E, but he might find out about it eventually, right? Let's say that happens on the next cycle, that C finds out about destination E, and he finds out that he can get there via D, and the total cost is 3. So let's say eventually there's a D3 in here, and then this guy here has a D6. So let's say this information was in there. So then what would go here? Right, so what we're trying to do is we're trying to get from A to, from A to E. So we list A's neighbors that he could talk to, which are these guys, and then you look at each one of those neighbors and see what they know. So B knows, what do they know about E, where we're trying to get to, right? So B knows about D, and it's 6 away, right? B knows about E, and it's 6 away. Let's say he knew that already. And then C knows about E, and it's, we're trying to do C knows about E, and it's 4 away via D. So C tells A about, you put the D3 here, basically. Just who knows what about what. You basically list the adjacency list. Well, you're doing row column, so you list you do this A to E thing, you write that down. And then we're trying to get from A, so you write down A's adjacency list. Then for each one of these, like for B, you write down, what does he know about E? B knows about, for E, B knows about E that he can get to E via D6. So you put the D6 there. And then the C knows about E, that he can get there via D. So you put the D3 here. Okay, this is like the mechanical process that you can follow, and even it's a little bit bad, but at least it's reproducible. And then you add these. This is 7. and this is 5. 5 is better, so you bring the C down, right? And that's the answer. That's what goes here, C5. Does that make sense? So let's see if it does. So what it's saying, this C5, what it's saying is that A can get to this guy E via C, and the total cost is 5. And it's 1, 2, 3, 4, 5, 6. Oh, shit. I'm off by 1. A can get to E via, it should be, let's check. B is, can get to E via D, and its total cost is 6. D6 is correct. And then C can get to E. The total cost should be a 4. D4. So this is D4, 6, C6. Anyway, that's what you do. It's kind of a pain, but go ahead and give it a shot. And I'm skipping steps here, but figure out each one of these values and use this little process right here. I hope this helps. There's a couple of examples posted already with the complete answers that should get you through this. It's really not that bad once you get into the routine of the thing. Let's see, what can we say before we leave? In the end, we have forwarding tables. So if you look at row A, the only letter values that are going to appear in row A are A's neighbors, just B's and C's basically. There's a B there, there's a C there, there's a C there, because we're just interested in the next hop, like who does A have to send information to get to some final destination. So it's just going to be, for row A, it's just going to be B's and C's. And for row B, it's just going to be A's and D's in here. You just see A, D, 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 and, like that. Likewise, for row C, it should just be A's and D's in here. Row C, there's an A, there's a D, A, D, D, D. Oh, wait, that's row B. But anyway, okay? Good luck. You can do it. It's messy, inherently messy, but it's good stuff. And do your best. Thanks.